Well, a warm welcome to anyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook. You can grab a pencil or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have a quick little look at arithmetic sequences and series. A sequence is basically a pattern / list of numbers determined by some rule. And specifically, when we have an arithmetic sequence, the rule involves either adding repetitively or subtracting repetitively to get to the next term. So, I want you to consider the sequence 7, 10, 13, 16, ... And I want you to find or identify the following. Also, there's a bit of a bonus challenge here. On my fourth birthday, I started saving money in a piggy bank. I put aside 3 cents the first day, 8 cents the second day, 13 cents the third day, and so on. So this is how much I was adding each day. I was adding 3 cents, and I added 8 cents, and I added 13 cents, so on and so forth. Until eventually, I realized that I had $1.64 in my piggy bank. Now, that was a significant amount of money decades ago. After several days, I had $1.64 in my piggy bank. So the question is, how many days was I saving up for? All right, so go ahead and give yourself about 7 or 8 minutes to try to answer these questions. You can pause the video, give yourself a chance to figure it out. Then when you're ready, come on back and see how we did it here. Now, I'm not going to go into the deep theory of sequences and series. However, I am going to reveal a couple of important formulas that you would need to use in order to solve some of these problems here. So A1 basically stands for the first term in the sequence. So A is just what we're calling the members of the sequence. And if you imagine that they're in line following one after the other, we can call this like AN. We can call it A1 means the first member, A2 means the second member, so on and so forth. So A1 is simply the first term here. If we wanted to label these kind of like the pages of a book, this is not division. In fact, I won't write a sign there. I'll just kind of leave this box open. Wow, bad box. Kind of leave this box open. So this is the first term, this is the second term. There you go. The first term is pretty clear. Now, the common difference, D, there's a way to calculate the difference. Since every term either adds or subtracts this difference, D, the common difference is defined by this formula. AN minus AN minus 1. So you can take any two successive terms, that means one after the other, you can subtract them, and that gives you your difference. So like the difference between A3 and A2 tells us how far away they are. Or if we wanted to look at the difference between A2 and A1, that's the same thing as trying to find the difference between A27 and A26, right? So if we take two numbers one after the other and subtract them, we get the difference there. So let's go ahead and calculate this. We can just take the first two values. It's pretty easy to say that D is equals to 10 minus 7. We could also have said 13 minus 10. We could also have said 16 minus 13. Either way, we get a value of 3. Okay, so far so good. Now let's look for the 11th term. In order to find the 11th term, we would have to add 3 multiple times. Right, so if we started at number 7, that's my A1, I need to add the common difference of 3. But if I add it once, that will only get me to the second term. How many times do I need to add it to get to the 11th term? I need to add that common difference 10 times. Think about it this way. If you're on the first floor and you need to get to the 11th floor, you don't go up 11 more floors. You only go up 10 floors. So this common difference is applied 10 times, and this is going to give us 7 plus 30. Very easy, 37. Great. Now for an, the nth term, let's use the same logic here. This is going to provide us with another formula. So here's an important formula that I have in purple for the common difference. The next important formula is going to be the an. An is simply equal to a1 plus n minus 1 times the common difference d. Sometimes they'll write it in a slightly different order. They might put d times n minus 1. That's pretty much the same thing. And what this stands for is it stands for the number of jumps to get to the nth term. Whereas this represents our starting point. So if we start on the first floor, so to speak, then we have to make n minus 1 jumps to get to the nth floor. And so for this particular sequence, we're going to say that an is equal to the starting point 7 plus the common difference of 3 times n minus 1. And there's a way to simplify that if we just distribute this. So really we can say that an equals to 7 plus 3n minus 3, or we can simply call this 4 plus 3n. So what this does, guys, is this gives us a formula so that I can find the nth term right away. I don't need to count one by one. I could just say, what's the 50th term, and just plug in 50 for n, and that would tell me the 50th term. Apparently it's 154. Okay. So that is how we deal with sequences, which are basically the numbers on a list, and the list is determined by some kind of a pattern. Yeah. Okay, great. Let's take a look at this sort of word problem about my history. It may or may not be true. The numbers are maybe a little bit different. If I started saving money in a piggy bank, then the amount that I've accumulated is going to be determined by a series. Now, a series, if you know, like a TV series, it's all of the episodes together, kind of. So it is the sum, or the total, of the sequence numbers. So we're adding numbers on the sequence together, and that follows this circumstance here, because I have 3 cents that I'm putting in the first day, and then 8 cents that I'm putting in the next day, and then 13 cents, and eventually I'm putting in an cents. I don't really know how far I have to go, but I do know that if I add those all up, 3 plus 8 plus 13 plus some value plus an, this needs to equal 164 cents. That's $1.64. So how do I write the sum for this? Well, there's a formula, fortunately, for the sequence, for the arithmetic sequence, we have a sum formula. That formula is as follows: a1 plus an times n over 2. So we need to be able to fill in our information. We know that this is going to equal 164, and we also know that the first term is a 3, but we don't know what an is yet. We're going to have to use the formula from our previous exercise, and we don't know what n over 2 is because we don't know what n is. The goal here is to find out what n is. How many days was I saving for? In other words, they're basically having us find n. So we can't do that unless we have an expression for an. Remember that an equals the starting value plus the common difference times n minus 1. Since we're starting at 3, can you identify the common difference here? Yeah, the value for d is just going to be 8 minus 3. Or you could have done 13 minus 8, or you could have done something else probably, and that would either way get you 5. So here we have 3 plus 5 times n minus 1, which we can simplify to say 3 plus 5n minus 5, and we can simplify further to say 5n minus 2. So this is our an. Very interesting. Let's go ahead and use that. This is going to give us 164 equals 3 plus 5n minus 2, and then this is all multiplied by n over 2. We got some rearranging to do inside of the parentheses. So this is going to be 5n plus 1 times n over 2 equals 164. Let's go ahead and multiply both sides by 2 to get rid of this 2 here. And that gives us 328 equals 5n plus 1 times n. And once we distribute this, you're going to see that this turns into a quadratic. So 5n squared plus n equals 328, which means that 5n squared plus n minus 328 equals 0, and that's a quadratic that we can solve. Very interesting that this turned into having a quadratic. We can simply use the quadratic equation, negative b plus or minus the square root of b squared. Our b is 1 because there's really a 1 multiplied to the n, minus 4 times 5 times negative 328. And if you're not looking forward to multiplying that out, I'm sorry, but you have to. So what are we going to have here? We're going to have negative 1 plus or minus the square root of 1 plus, do you know what this comes out to be? 1 plus 6560. Believe it or not, that is going to work out nicely, because the square root of 6561 is just 81. So on one hand, we get negative 1 plus 81 over 10. And on the other hand, we can possibly get negative 1 minus 81 over 10. We're going to reject this answer for 2 reasons. The main reason being that we got a negative. We can't have negative days pass by where I'm collecting money in my piggy bank. And also, we don't want a fraction because there can't be a fractional amount of days. We need to get a nice, whole, clean number. And in this case, we get 8. So over the course of 8 days, putting more and more money in the piggy bank, the same amount more every time. I put 5 cents more every day. After 8 days, I'll have $1.64. Okay, this covers the arithmetic situation. Stay tuned for the next video. We're going to cover the geometric situation and some comprehensive practice examples. That's enough blab out of me. I'll see you guys next time.